Hey everyone, I'm Benjamin Baxter, developer advocate for Android TV. Today, we're going to talk about building a great Android TV app. So before we dig into details, let's talk about the ecosystem. We continue to see 2 times year-over-year growth. We're investing more in smart TVs, set-top boxes, pay TV operators. The ecosystem's been pretty strong. But we're all developers. Let's get into how can you make a good TV app. So before we talk about what the innards of your app are, let's just think about what is a TV? Why is it so important? We have entire living rooms or other rooms dedicated and focused around a TV. It's a pretty key point for users. It's the focus of an entire room. Just think about that for a second. So your app matters. The content really matters. So if we try to think about what is the foundation for an app, the biggest piece is your content. That's your value prop to your user. If we add on to that, usability. How do you make your app easier for users to use? You have great content. How can they discover more of your content inside your app? And if you want to get that little cherry on top, think about the experience. How can you layer in all these extra things to build a sweet experience for users, no matter where they are in your app? We'll dive into each of these concepts, and I'll call them out later on. But the key takeaway is they come for your content, but they stay for your app. So now let's talk about how do you build a great TV app. There's really 3 things to think about. Playing, because content's important. Discovering, making sure they can see other content in your app easily. And distributing, making your content easy to find should be as easy as making your app easy to find. So let's talk about the player. Playback can make or break an app. Let's take a look at this review. Feel free to read. So the key takeaway for me is that it constantly stalls. This app is completely frustrating. They ended up with just a 1-star review just because of their player. And reviews matter. There's whole other talks about Google Play and how to improve your reviews. But the player was the key point here as to why their app was not as good as it could be. So it's very clear to users that the playback is important. They don't want to have stutters and stalls. They want to be able to watch the content. And even in that review, they talked about commercials and ads. And they were okay with it. They just didn't like that they stalled. So even showing things that may be annoying, such as commercials, as long as they play fine, users are okay with it. So the player, we have many options to build a good player. Media player is a great tool, comes out of the box in the framework. You give it a data source, it's able to chug along and play, and you can build a great experience with a media player. If you have more advanced things you want to do, Exo Player is another great tool. We've worked really hard to make it highly customable. There's a bunch of extensions. If you're using leanback, there's an extension that hooks into the leanback transport controller. If you're doing ads, there's a whole bunch of ad stitching support. But let's talk more about ads. Ads are important. Your app's going to make money from showing ads. So in a sense, ads are just as important as the content shown and displayed to the user. So focus on ads. Make sure that ad stitching works. Whether you should do it server side or client side, these are real considerations you should make for your app. So there's many options for players. Media player, Exo player, build a custom player. But having a player is a good start. But there's things you can layer in. That top part of the pyramid, the experience, there's things you can do to build an experience around the player to make it even better. So we talked about this at I/O this year, playback controls. Everyone's phone should be ready. Here we go. OK, Google, skip 5 minutes. OK, Google, pause. OK, Google, play. These types of transport controls can be commands through the assistant. Adding this extra little feature, this little nice nougat of delight, helps build that experience for your app. This all works with Media Session. So if you implement Media Session callback, you get all of these features for free. And since I talked about this at I/O, and there's been other talks about media session from other people, I'm going to just jam through this fast. Pay attention. Here we go. Boom, beautiful. 6 wonderful methods: pause, play, stop, seek, next, and previous. But in reality, like, that's a lot. It's a lot to think about. All these different cases. But if you use ExoPlayer, this can be done for you. So they've made an extension that manages media session for you. All you have to do is connect the player to the media session, and it all works for you out of the box. Making a media session is also pretty simple, and there's tons of documentation and talks about media session. I'm not going to go too deep into it, but you just need to make sure that you set the media session to be active, set the controller, set anything else you need to set. Set the current state. Are you currently playing? What position are you in? Set up your media session to be what you need it to be. And once you have a media session and you have an ExoPlayer instance, connect them. So there's an extension library, media session connector for ExoPlayer. Here you just add in the media session as a constructor parameter to the media session connector. And then you set the player to your ExoPlayer instance. This media session connector understands how to set up the callback, all the edge cases around playing and seeking. You don't want to go past the end of the video. You don't want to rewind before the video starts. It handles all those edge cases for you. In this example, we are saying set player, and then null. You can set a custom playback preparer. There's other customizations you can do as well. So if you're a music app and you have a custom playlist and you want to set a different order for how the songs go through the queue, you can set a custom queuing mechanism on the extension. That's it. 3 wonderful lines of code, and assistant's already taken care of for you. All of the default behavior you expect, done. So having a great player is great. That was just one example of how to layer in that experience to make a player even better. We're going to skip ahead to discovering content. So the whole point of discovering is you want users to stay in your app, and you want them to discover and watch content faster. So let's look at this review. I love the first sentence. They love, love, love. So many loves this app. So the key takeaway here is it was a 5-star review, and they loved all of the content was there. Easy to find. They can do whatever they need to do inside that app and watch what they want to watch. Funny story, that's the same app that got the 1-star review. So even though they had a bad player, they worked on discoverability, and they're still able to have good review in the Play Store. So how can we make content discoverable? Everything kind of happens in 3s, and that's like a rule of comedy. It's a really good rule in life. In this case, discoverability also happens in 3s. You can work on in-app browsing, search with the assistant, and the home screen. We'll start with in-app browsing. There's a beautiful library, leanback. If you've done TV development, you're very familiar with it. It's a templated UI system for you to just plug in data, and it works on building the UI for you, so you don't have to worry about all the focus handling and all the user input. You can just supply, hey, here's the content we have, and it will show it for you. It's not just how to browse content, though. Leanback also works and shows details. So there's a whole bunch of information about content. You have duration, content rating, the Rotten Tomatoes score, the album, artist, and I can keep going on for the rest of the 30 minutes of this talk, but I think you get the point. There's tons of information. The cool thing about it is you can show it using leanback, but you can also show it in multiple other places on the home screen in search. And by showing all this information sooner, it lets users make these micro decisions much faster, and they don't have to go in and out to figure out what they want to watch. So make your users' lives easier by showing them all this data sooner. Let's look at another example, search. Again, we talked about this at I/O, and there's tons of documentation on this. So I'm going to kind of breeze through some of these things quickly. Search is all supplied with a content provider. Content providers are pretty simple. They return a cursor. You're able to do whatever you want in the background with this content provider. So boom, magic content provider. You perform a search, and it returns results. If this did a network call, maybe you have a bunch of POJOs. If this was a database call, you're going to have a cursor. And that's fine. The trick for the search provider is that it needs to return results that match the search manager's criteria. So search manager is just a strict way of saying, hey, this cursor has a bunch of columns with these names. And then the assistant's able to pull in from that cursor and say, oh, here's the title, here's the duration, and is able to figure out what content's where. Super simple to do with matrix cursor. And we'll dive into this a little bit closer. You just need to take each of your results, add them as a row into the matrix cursor, and then return the matrix cursor. The matrix cursor is really just like a mock cursor. It's a 2D array, essentially, under the covers. So if you don't have to go about, how do I store all these in a database with these column names, you can just mock it out at the very end of your search. So mapping, this is where the hard work happens. You have a matrix cursor, and it takes in a query projection. This query projection is going to have all of the columns defined that match the search manager. So here we have suggest column text 1, typically is the title of the content, an action, a data ID. The ID is what's unique to your content inside the app. And then when you go to convert your content into this row, you just supply an array of objects. Here's the ID, here's the name, and they correspond to the order in which that query projection was. So the ID, the title, the action, etc. All the fields you have, you can return back. So a search manager, and with searching with the assistant, you don't have to do all this extra work. You can use matrix cursor to make that returned result much faster. Homescreen. We've talked about the home screen for the past 2 IOs, so I'm not going to talk about the old. I'm just going to briefly cover it, and then we'll talk about some of the new stuff that's happening. The home screen has 3 key parts. Your app can have a channel, your app can iterate with the play next row, and for video apps, you can have video previews. We've seen up to 2x increase in engagement when apps have video previews. They look wonderful. They can be as simple as a trailer for a movie or a recap for a TV show. But they take a little bit more work because it probably requires a content team to make that content for you. I'm not going to talk about Play Next or video previews since we talked about 4, but let's dive into channels. So just to recap, building a channel is just inserting into a content provider. We have a channel, we get a builder, we set the type to type preview, we give it a name, a description, a deep link, so when they open up your channel, it's able to open into your app. And you set an internal provider ID. This is an ID that your app wants to keep track of and knows about. Then you just get a content resolver, you call insert, you give it content values, and you're good to go. Once you've stored your channel, you parse out a channel ID. You do some stuff, maybe you want to keep track of that channel ID for synchronization. And then you set a logo. So channel really consists of a name, a description, a deep link, an internal provider ID, and a logo. Those are really the key pieces of a channel. So what just happened? We created a channel, we inserted it, and we stored a logo. So we really did 2 things with the home screen. Insert the channel, store the logo. So as of Android X 1.0.0, we have a new API. This API looks very similar, small differences. We have a preview channel helper class. It takes in a context, and then it does a bunch of lookups to get the content resolver for you, so you don't have to do context.contentresolver.insert. It does all this work for you. It makes a channel. So you have your builder, you set the name, the description, the app link, and the intent provider URL, and you think you should set the type. But this class knows that it is a preview channel, so it already knows the type is type preview, and you don't have to set the type. Instead, you can set the logo. Now, all this stuff is contained in one unit, and you can just call the helper.publish channel, give it the channel, it figures out all of the work for you. And you get the channel ID back. So what it does under the covers, it inserts the channel into the provider, and then it goes to add a logo. If the channel isn't able to be inserted, maybe you have bad data and you're hitting an error or something, it will return an error back to you. If it is able to insert the channel, it tries to store the logo on that channel. If the logo cannot be persisted, it throws an exception, wraps it all up, unwinds adding the channel so that you don't end up with like half a channel on the home screen. It essentially treats everything as an atomic unit. Pretty convenient. It doesn't just publish channels, it does everything CRUD does. So we've already talked about publishing a channel. You can read all of the channels. You can even get individual channels. You're able to update a channel, and you can delete them. And I'm only talking about channels, but all of this also happens for preview programs. And there's also support for the Play Next row in this class. But there's two options to do it. Which one's better? You could say, I just want to use content providers. I'm able to fine-tune the performance. I can do batch inserts, bulk operations. I can get lower level control. I don't need an entire program with all that metadata. Maybe I just want the title and duration. And now I can slow down that query projection and have faster results. And it's based out of the framework. You don't have to do all this extra work to access it. You get it out of the box from the framework. But if you want to use Android X, you get more convenience. You don't have to worry about all the nuances of a content provider. It's a one-liner for all intents and purposes. And you get all the fun benefits of having the Android X in your app. So discovering content's great. There are 3 ways to go about it. In your app, searching with the assistant, and on the home screen with channels. But how do you make your app discoverable? The third thing. The App Store on TV is a bit different. It filters out a bunch of content. It wants to make sure only apps that are designed for TV will be shown. So when the user opens up the App Store, they're only looking at apps that can be played on TV or can be installed on TV. Trying to navigate the Play Store and make your app stick out can be hard, but there's 3 simple things you can do to have your app appear on the Play Store. First thing is to declare features. And as slide says, even if you don't use it, there's a giant asterisk. Don't start declaring like Bluetooth just for fun or location just for fun. There's 2 features that really matter. So the first one is touchscreen. You want to declare that as false. It's not required to have a touchscreen. This isn't a phone. This isn't a TV from way back in the day. These are smart TVs. You don't need touchscreen support. The second thing is to declare leanback as true. This tells the Play Store, hey, this app is designed and ready to be deployed on a TV. But if you have all of your code in a single code base and you're making a single APK that deploys on both mobile and TV, set leanback to false. This still tells the Play Store, hey, this APK is compatible on both mobile and TV. The second thing you should do is try to be visible in the launcher. Now, if you're a headless app like a screensaver or a keyboard, just go away for 2 minutes, and I'll see you then. So to make your app visible on the home screen, you need to supply a banner. You can define a banner in application, or you can set it in your activity. The launcher will go in through the manifest, find this resource, and this is what it uses to show your icon on the launcher. But once the user selects your icon, it needs to launch something. So the launcher fires an intent, and you need to have an activity that accepts this intent. It's called the leanback launcher intent, really cleverly named, does exactly that. So from the launcher, it will trigger off your leanback experience. So there's 3 things you need to have. 1, declare the 2 features so that your app will be found on the Play Store. 2, have a banner so your app shows up on the launcher. And 3, have a leanback intent so that your app launches when the user wants to enter your app. And that's it. You're ready to go in the Play Store. This talk is done. All right. But in a sense, that's kind of the minimal viable product. You're able to have a strong player, you're able to have easy to find content, and you're able to distribute on the Play Store. That's just a good app. How do you make it great? To start with this, you should look at your users. Imagine all of your users on a spectrum. They start from one side of the spectrum. Hey, I bought a TV because it's cool, Everyone's doing it, I want to be cool. Sits in my closet, but I have a TV. The next side of the spectrum, oh, I love watching TV. Every week I watch this show. This is great. You go a bit further down, oh man, I love How to Get Away with Murder. Viola Davis is awesome. Hey, maybe I should watch Suicide Squad. She's also in that. Then the far extreme, maybe the better examples for sports. Hey, I'm watching the sports ball game. Here's a fantasy team. Here's a jersey of the player I like, and I just want to keep going and going into it. The side on that side, the left, is what's called the leanback user. They're just going to be sitting back watching TV. That's all they want to do. The side highlighted, this is what you can call the lean-in user. They're sitting on the edge of their seat. Oh, man, this is awesome. Who are these people in this show? And they're going deeper into the content. Everything we've talked about up till now, having a good player, making your app usable, this is more for the lean back, the right side of the screen. But if we think about it, how can we tap into that lean-in user? Here we have another living room, a very beautiful living room. I wish it was mine, but it's not. But if we look closer, you'll see a camera, microphone, tablet, phone, and then as you start to think about it, the TV is the centerpiece of a living room. There's so many devices around. You don't have to just do stuff on TV. You can tap into everything around the living room. That's why I love Android TV. It's like the focal point of everything that's happening. So in concept, again, we're going to do this in threes because threes are great. In concept, if we want to tap into these other surfaces, what should we look to do? First step is just controlling media. The playback controls we talked about earlier is a great step. It's going a little bit farther advanced. You're building an experience around your app. Maybe for another option is to have notifications. Hey, the big game's about to start in 5 minutes. Do you want to watch on your TV? Second pillar is more about going deeper into content. Who's the cast and crew? What are the behind the scenes of this production? Are there extra sponsored content that I want to know more about? And then the third pillar is about reducing friction. How do I install your app? Okay, it's installed. How do I sign into your app? I want to make a payment. How do I authenticate that payment in a secure way outside the TV? So let's look at an example. You may or may not know it, but everyone here who's set up an Android TV has already done that third step, that frictionless interaction. The Android TV setup actually does this for you. During the flow, they say, hey, do you want to set up on the phone? They give you a strong UX indicator. You're going to pull out your phone. You get a notification. You say, hey, yeah, this is me. This is my account. And the TV takes over from that information. And it was really frictionless. But how did they do that? It's not magic, I promise you. It's something you can do today. You can use Nearby. So the Nearby API has been out for a while. But it's really interesting when you try to use it on TV, what you can do. The way it works is you're going to set up the TV to be the advertiser. And then the phone's going to come out and try to discover, hey, there's the TV. You do all the work you want to do on the phone, and then send it back to the TV. Nearby is going to set up an offline peer-to-peer wireless connection that's encrypted, and you don't have to worry about a lot of things because you're going to have this intimate connection between the phone and the TV. Let's dive a little bit deeper. So getting started with this, let's start on the TV side, because I'm on Android TV, so I'm a bit biased. We're going to start on TV first. TV is going to start advertising. The way you do this is you set up nearby.getConnections client. Nearby is just a nice singleton helper class from the Nearby API that has all these things to help you get started. You call start advertising. You're going to give it a name, a service ID. Package name is perfectly fine. you're going to give it a connection lifecycle callback, and you're going to set a strategy. Cluster is a really good strategy. If you notice, there is also a P2P point-to-point strategy, and you might be, yeah, it's one TV, one phone, point-to-point. This sounds great. But if you try to do like multi-device setup, I have a TV in my living room, one in my bedroom, one in my bathroom, all of a sudden that point-to-point breaks down. So to make a more robust app, you should think about using cluster. You also set success and failure listeners. Now these listeners aren't saying, oh, I've been found, I've advertised and now I'm found. These listeners say you are able to start advertising. So they're great for debugging and adding extra information inside your app. The big elephant on this slide, though, is the connection lifecycle callback. This callback talks about how the devices will talk to each other. You know, what's going to be said is later, but how are they going to say it now is handled in the connection lifecycle callback. Simple 3 methods: uninitiated or uninitialized, results, and disconnected. They're pretty straightforward, but let's dive in a little bit more. So when a connection is initialized, that means the phone requested a connection. You're going to prompt for security and do a couple things, but eventually you're going to say, nearby.getConnections client, accept connection. Once the connection's been accepted, you'll receive a result. Based on that result, was it okay? Continue on. Was it rejected? Maybe ask for another retry. But based on that result, you should handle appropriately. And the last one on disconnected is pretty simple. Just clean up any metadata you may have started collecting. The big line here is the connections client accept connections. And here you pass in a payload callback. This payload callback is going to be what the devices communicate. So you should have a contract on your phone and on your TV for what they're going to say to each other. Hey phone, we want to do this. Hey TV, we're going to do this. This is all handled inside the payload callback. So here are a couple tips. What you're going to communicate is very specific to your app, but here are some tips. The payload received and payload transfer update are the only 2 methods you get. They're pretty succinct, pretty good methods though. On payload receive, if you want to send an acknowledgement back, hey, thanks for telling us this phone. We're going to send back an acknowledgement so you know the message has been received. It's really easy. You just call send payload. You give it the endpoint ID that you received the payload from, and some body. In this case, it would say ACK or acknowledge. If you want to disconnect, hey, I received this payload. I want to disconnect the connection and close this session. You should do that in the transfer update. In the transfer update, you should check to see if it's in progress or not. If you're sending small messages like ACK and send, those are pretty fast. But if you're sending something big like a file, that could take a while, and you want to check to make sure all the bytes have been sent. Once all the bytes have been sent, then you can call disconnect from endpoint. So to summarize the TV side, you're going to advertise, hey, I'm a TV. You're going to accept the connection, and then you're going to communicate. But on the phone, what happens on the phone side? It's going to look very similar. You're going to discover the TV this time. You're going to request the connection, and then everything after that is going to look like the slides I just showed you. So to discover the TV, you have the nearby connection client again. This time you call start discovery. Mind blown. You're going to give it a service ID. Now this time I'm using a constant, and there's a reason for the service ID. Depending on your app, should either be the package name or the constant. If you have a package name that's the same for both your TV app and your mobile app, it's going to work great. But if you have something like com.mycompany.android or com.mycompany.androidtv as your 2 package names, imagine they're kind of on their own channels, and so the nearby connections library won't be able to find the phone and the TV. So having a service ID that's used by both sides is a good practice. Then you're going to give it a mobile endpoint discovery callback, because I love really big words. And then you're going to set a strategy. This strategy should be symmetric to what you set on TV. So I urge you to use cluster for this use case. You get listeners again. These listeners are pretty important. These say you are able to start discovery. This does require location permission because it's going to use Bluetooth LE, then default to other ways to find nearby people. So if you get a failure listener, maybe it's like, oh, permission for location hasn't been enabled. So these are great for debugging and trying to urge the user down the correct path. So the second part, accept the connection. Really simple. You have that mobile endpoint discovery callback, and it has two methods. You either found an endpoint or you lost an endpoint. Pretty simple. If you find an endpoint, go ahead and request a connection. This will trigger the on-connection initialized on the TV that we saw earlier. If you lost an endpoint, maybe the user walked too far away from the TV and is now no longer nearby. Or maybe they gave up and just closed the app and said, forget it. Hopefully it's the first for you, not the second. You just clean up whatever metadata you had collected already. Everything after this is identical. You're going to have a connections lifecycle callback that handles how they communicate, and then you're going to have a payload callback that says what are they going to communicate. And that's it. That's pretty much Nearby in a nutshell. But Nearby is a cool tool. It's nice to have in your toolbox of kits for how to add more experience to your TV app. So let's go down payments. Let's look at one more example. Payments, I think, is kind of cool. It adds this family-friendly idea. Imagine you're at work and your kid is at home and they want to buy the next season of a TV show. You get a push notification, hey, are you sure you want to purchase this TV show? And you say, oh man, my kid's at home buying stuff. No. Or, oh man, my kid's at home. Yeah, they're bored. Let me use my fingerprint or Face ID or anything from the phone to authenticate yourself. And all of a sudden, you just enabled a purchase at home from your office. I'd argue that's not Nearby. If there was an API, it'd be called far away, right? And Shrek might have been as close to far away as I've seen, but I have not seen that in Android. So in this case, Nearby is not a good fit. It's a good tool in your toolbox, but it's not necessarily the best fit. Maybe there's another good fit. Let's talk about that example one more time. You get a push notification, and it says, watch on TV or watch here. This is the big game. You want to watch it. Watching on a small phone, watching on a big TV, awesome. You could use Nearby to figure out proximity. Yes, they're close to the TV. We should show the Watch on TV up button. That's a great use for Nearby. Receiving the notification, this is a great example of content immersion. As soon as you said Watch on TV, the background lit up. You're in this immersive view. Here's the schedule for the game. Here's some highlights. Here's the score. And then whenever the user wants, they can just put the phone to the side. It's very non-intrusive, and they can focus on the game. So in a sense, this was kind of kicked off from a notification. In a way, you would say, hey, that was more of a push model. Nearby feels more like a pooling. I'm pooling a conversation between the two devices, whereas in this case, you're more of pushing that information to the user. And there's a talk about Firebase Cloud Messaging after this, and I won't step on their toes too much, but we'll just talk about it for fun. What's the worst that can happen? You set up a Firebase messaging service, you receive a message, based on that message, you should have some action. Here's what to do when you receive that message. If that action happens to be, hey, watch this movie or watch this game, start watching, and you're good to go. Start watching literally should launch an activity. This is the Android Dev Summit. I'm assuming everyone has launched an activity before, but just in case. We set up an intent, we give it some extras like, hey, here's the video to watch, and we start an activity. Beautiful. The question really comes down to what happens when the TV screen is off. I'm at home, I get a push notification, oh man, the game's about to start. I have to hit power on my remote, I have to tune to the channel. This is first world problems at its finest. But you can solve those. We have that fragment activity that's your player. When you set up everything, all you have to do is just call set turn on screen to true. Now this is a really cool API on activity. This is actually introduced in OMR1. So if you're on API 27 or higher, you should do a check. Hey, turn on screen to true. Otherwise, you can just add the flag. So to summarize how to build a great TV app, start with your player. Your content is king. So really focus on the player. Whether it's an ad or whether it's actual content, make sure your player is solid. Next thing, how do you make your app more usable? How do you get that lean-back experience so that users can quickly find other content to watch? The third pillar is distribution. Is my app set up to be deployed on the Play Store correctly? Once you have all three of these, you end up with happy users. And who doesn't want happy users? But if you want to take your app even further, evaluate your users and layer in these lean-in experiences. How do you do payments, having that push notification for that media control? How do you add that immersive content? Here's the details of the game. So thank you. Everyone, go build great TV apps.